Bereshit bara Elokim et hashomayim ve'et haaretz. In the beginning, God created the heaven and the earth. This opening verse from the book of Genesis describes in one simple phrase that God created the world.
Aham sarvasya prabhu matak sarvam pravatate iti matva bhajante mam buddha bhava samanvitaha. I'm the source of all spiritual and material worlds. Everything emanates from me. The wise who know this perfectly engage in my devotional service and worship me with all their hearts.
Most religions believe in a universe created by God. Science puts its faith in a different story. 15 billion years ago, there was the Big Bang. It produced a universe of hydrogen, helium, and radiant energy, heat, light, X-rays, and so on. Since that moment, the universe has been cooling and expanding evenly, but slight variations in density cause gravitational fluctuations that become the seeds for the formation of stars and galaxies. Within these seeds, gravity pulls all the surrounding hydrogen into gigantic bundles. When it gets concentrated enough, it explodes like an enormous hydrogen bomb. But instead of flying apart, gravity holds it together, and it just sits there in space, a huge glowing sphere we call a star. Meanwhile, gravity's been busy. The same process makes 10,000 million other stars, and because they attract each other, they collect in giant groups called galaxies. So there's our universe, thousands of millions of galaxies. This is the hot Big Bang theory.
Let me just show you some pictures of the galaxies. I have this nice catalog here that has a lot of pretty pictures of galaxies. Over here, for example, is Messier 81, one of the nearest, most beautiful galaxies in our close vicinity, big spiral galaxy here. And over here, there's another galaxy, not so well known. It's a later system, more open. And when I was looking at these pictures, I was just noticing how there are these background galaxies. Here's a little background galaxy, another spiral, and another one up here. And if you keep on looking, you see even more distant ones here. So as we look deep into space, there are foreground objects, there are background galaxies. But they do tend to cluster. They do tend to like to hang out together in groups. And now the big new thing is they hang out in filamentary structures. And these filamentary structures are turning out to be huge, far bigger than we could have expected. And that's what my video shows over here. And these green blobs are not individual galaxies. They are places where there are a lot of galaxies. And so it has a red core. That could be a cluster of galaxies.
The hot Big Bang theory predicts that these galaxies should be more evenly spread. They're not. Even when you look at 10% of the whole visible universe, galaxies group together to form colossal structures that look long and stringy. The two cones mark the position of our galaxy, the Milky Way. So how could the early gravitational seeds produce these huge structures?
Frankly, we don't understand it. We don't understand how these seeds could have been so prominent. But that then is one of the things at the frontier of science. That's what we're working on today.
We in Judaism believe that God was there. God created this mass. We say it's energy, they can say it's material. People will interweave those words. But nevertheless, as far as Judaism is concerned, we believe that God created the world, God will always continue to look after the world, and that's the meaning of the opening words. In the beginning, the very beginning, before anything was there, God was there, and it was he who created something from nothing. He created this energy, and now today we are living in a world still under his supervision.
I take the Big Bang Theory absolutely seriously. I'm a scientist, and it tells me that the universe, as we know it, started about 15 billion years ago. It started very simple, just a ball of energy, and it's now become very complicated, so it has you and me and all sorts of interesting things in it. That's the science's story, and it tells us how things happened. But I also want to know, is there something going on? Is there a meaning and purpose behind all that? That's a question of why, and that's a religious question. And I don't have to choose between believing in the Big Bang as a scientist and believing in God the Creator as a Christian. I believe in both, and I need both to understand the world.
We do not believe in the Big Bang at all. We believe that everything emanated from God or the Supreme Person.
It has now been realized that there is a way in which the laws of physics can determine how the universe should begin. If this is correct, it will not be necessary to appeal to God to decide how the universe began. This does not disprove the existence of God. It just removes the necessity to suppose there was a God who lit the blue touch paper of the universe.
A cloudy island in the middle of the Pacific seems an odd place to put a telescope, but on the big island of Hawaii there's a mountain 4,200 meters high, way above the clouds. Mauna Kea is the finest place on Earth to view the stars, and now the biggest telescope in the world is being built there. When it's finished, the Keck telescope will have a mirror 10 meters across. The mirror's only half finished now, but it's already been used.
We've taken some pictures of galaxies, and here we have two pictures of NGC 1232. This is a relatively nearby galaxy. It's about 100 million light years away. This was taken with a Keck telescope when we had 9 mirror segments in place, so this is a 5-meter telescope. This is only a 1-minute exposure, so here, with a 5-meter telescope in a minute, we've taken an excellent picture. The light we see from this galaxy left that galaxy 100 million years ago, and it is just now arriving here.
The larger the mirror, the more light it collects, and it's the mirror that makes this telescope special. It's made up of individual hexagonal mirror pieces all joined together. There will be 36 of them when it's finished. Each mirror piece has rods attached to the back that actually bend and change the shape of the glass under computer control. In this way, the shape of the whole mirror can be made very accurate indeed. If this 10-meter mirror were made out of solid glass, it would bend under its own weight and distort the pictures. The Keck telescope uses visible light. This telescope uses infrared light that we can't see. So what extra information can we get from infrared light?
This is an optical image of a region close to the center of the galaxy. It shows that there are several stars present, plus some faint nebulosity. This is gas and dust which is reflecting the light of these stars. It's thought to be the site of active star formation. This means that young stars are being formed out of the gas and dust in this region. We went then to our infrared telescope and took some infrared pictures. Infrared is the study of heat radiation, and infrared radiation can pass through the dust and gas which is obscuring the sources. The two stars here and here in the optical photograph are in fact the two stars here and here in our infrared picture. And between them we find a very bright and peculiar shaped region of nebulosity. To enhance the picture and get more information from it, we represent the different brightnesses by colors. In this case, black is the faintest and red is the brightest, with intermediate colours representing intermediate brightnesses. We see lots of different features appearing, like wisps of nebula up here and here, and lots of faint stars which stand out better against the background.
If we ever want to leave this planet and live somewhere else in the solar system, we have to solve many mysteries about how the Earth works. To find out more, a unique experiment is taking place in Arizona. Biosphere 2 is the largest greenhouse ever built. It's as big as 3 football fields and 25 meters high. It's made of glass and steel and is sealed so tightly that no air or moisture should get in or out. Inside is a crew of 4 women and 4 men, the Biospherians.
Well, I'm the co-captain of the team and I'm in charge of daily operations. So overall, it's my responsibility to see that everything that needs to get done gets done. But on the whole, people just organize themselves within their areas. Everyone has their area of responsibility. And we follow a schedule whereby we try to get most of the daily operations tasks done in the morning, which would leave the afternoons more free for research operations.
In early 1991, the doors of the biosphere were sealed shut for 2 years. No supplies come in from the outside world except electricity and sunlight. Everything else they need is sealed in with them. They live in their own miniature world. There's an Amazon jungle, a savanna-type grassy plain, a marsh, a desert, and even a miniature ocean complete with waves. In fact, most of the environment's found on the Earth.
We've got to solve ways that we can keep the air quality of extremely high quality in Biosphere 2, because should something begin to build up, we have far less of a buffer, far less of a volume of air for that trace gas to exist in. So we can't tolerate the kind of air degradation that's now a major pollution problem on the planet. We have to solve in a very immediate way to the problem of recycling, making reuse of waste materials like what comes out of effluent from people, from our habitat, laundry water, dishwater, you name it, animal byproducts. We've got to recycle that material to keep our agricultural soils in good fertility. So we have to develop recycling systems that way.
Although the biosphere is completely self-contained, its systems are carefully watched from the outside.
The drinking water system in Biosphere 2 is a system that relies on a finite number of water in the biosphere. There's only so much water in there since it was closed, and no more. The water will come from different sources. One of the main sources is the condensation that occurs both on the glasses and inside the condensation coils, a kind of mechanical clouds, if you wished.
Surprisingly, this is not a government project. It was set up by a group of individuals.
And I think I had 2 main interests or desires that kind of fueled my work and inspiration on the project. And one of those is I'm extremely interested in long-term space habitation, and I'd like to think about people on the planet habiting some other parts of our solar system in the next 20, 30 years. I think we'll actually create new visions of how we cooperate with the planet that we live on.
Curious things happen in space, and a lot of them are to do with weightlessness. But can we recreate weightlessness on Earth? If an aeroplane is allowed to drop out of the sky, everything inside it is said to be experiencing microgravity conditions. That's like zero gravity. But there's a much cheaper and safer method of doing this. On the outskirts of Bremen in Germany, there's a very tall tower. It's about 110 meters high. That's the equivalent of a 50-story block of flats. This is the top of the drop tower. It's called that because they drop experiments down it. This capsule drops into a tank of polystyrene beads to stop it from smashing. And it all happens in 4.7 seconds. The experiments are mounted on platforms and a video camera records what happens inside. In this experiment, they're going to weigh the rock whilst it's falling. The experiments are sealed inside the capsule and the tower is prepared for action. To ensure that air resistance doesn't slow the capsule down, as much as possible is removed from the tower. The rock appears weightless because it accelerates at the same rate as the capsule. So the rock is not pushing down on the scale, which reads 0.
In dieser Schwerelosigkeitsumgebung führen wir verschiedenste wissenschaftliche Untersuchungen durch. So untersuchen wir das Verhalten von Flüssigkeiten und Gasen unter Schwerelosigkeit, die Verbrennung von Brennstoffen, das Verhalten von Einzellern unter Schwerelosigkeit, aber auch Polyreaktionen, das heißt also das Entstehen von Kunststoffen im schwerelosen Zustand.
This is how a drop of fuel burns in normal gravity, but it burns with a spherical flame in microgravity. By looking at the flame with laser light rather than ordinary light, they can study the disturbances in the air around it caused by the heat from the flame. This helps them understand how fuels burn in space.
Wenn man keinen Faltturm hat und möchte trotzdem Schwerelosigkeitsversuche machen, dann gibt es eine einfache Möglichkeit. Ein kleines Röhrchen mit Wasser, es könnte Glas sein, es kann auch Plastik sein, weil es nicht so leicht kaputt geht, und eine Luftblase oben drin dient zur Anzeige der Schwerelosigkeit. Wenn ich dies in die Luft werfe, wird in dem Moment, wo es meine Hand verlässt, Schwerelosigkeit eintreten. Die Oberfläche des Wassers ist nicht mehr plan oder eben, sondern wird jetzt kugelförmig, so wie es sein muss, wenn alleine die Oberflächenspannungskraft wirkt.
Bereshit bara Elokim eit hashomayim ve'eit haaretz. In the beginning, God created the heaven and the earth. This opening verse from the book of Genesis describes in one simple phrase that God created the world.
Aham sarvasya prabhu matak sarvam pravatate iti matva bhajante mam buddha bhava samanvitaha. I'm the source of all spiritual and material worlds. Everything emanates from me. The wise who know this perfectly engage in my devotional service and worship me with all their hearts.
Most religions believe in a universe created by God. So there's our universe, thousands of millions of galaxies. This is the hot Big Bang theory.
Let me just show you some pictures of the galaxies. I have this nice catalog here that has a lot of pretty pictures of galaxies. Over here, for example, is Messier 81, one of the nearest, most beautiful galaxies in our close vicinity, big spiral galaxy here. And over here, there's another galaxy, not so well known. It's a later system, more open, and when I was looking at these pictures, I was just noticing how there are these
galaxies. Within these seeds, gravity pulls all the surrounding hydrogen into gigantic bundles. When it gets concentrated enough, it explodes like an enormous hydrogen bomb. But instead of flying apart, gravity holds it together, and it just sits there in space, a huge glowing sphere we call a star. Meanwhile, gravity's been busy. The same process makes 10,000 million other stars, and because they attract each other, they collect in giant groups called galaxies. Science puts its faith in a different story. 15 billion years ago, there was the Big Bang. It produced a universe of hydrogen, helium, and radiant energy, heat, light, X-rays, and so on. Since that moment, the universe has been cooling and expanding evenly, but slight variations in density cause gravitational fluctuations that become the seeds for the formation of stars and galaxies.